Hello everyone, welcome to Dr. Ravi's Academy. In today's class, we will be understanding a problem on statically indeterminate problem of coplanar concurrent forces. CCF stands for coplanar concurrent forces. Let us look at the problem. You have three identical wires, OA, OB and OC. Three are identical wires and arranged such that the angle is 30 degrees and 30 degrees, symmetric about the vertical axis, and it is supported a load of 20 kilonewtons. And is asking, determine the force in each wire, that is the tensile force. The moment you apply the load, pulling load, tensile force is developed in OA, OB as well as OC. So 1, 2, 3, T1, T2, T3. Three forces you are supposed to calculate, and is asking these three forces, and not only that, is asking, so what is the vertical displacement? The moment you apply the load, it is subject to move downwards. You have a deformation. So this deformation is asking. So this is purely a statically indeterminate problem, and that you can conclude that the number of, this is a coplanar concurrent forces. All the forces are lying in a single plane and all are meeting at a point, all the forces. And you have T1, T2, T3, three unknowns. And as you know very well, you have two equations of equilibrium, that is sigma fx is equal to 0 and sigma fy also 0. So you can conclude this particular system is statically indeterminate problem, because the number of unknowns, here it is T1, T2, T3. So you have three. Number of unknowns are three, which are greater than the number of equations, or number of equations of equilibrium, that is 2. And the conclusion is statically indeterminate problem. That means you are unable to solve this problem just by using equations of equilibrium. You need to consider the deformation so that you will be able to have the consistent deformation, and that from that deformation equation you will be able to find out you are going to have additional equation. That equation is called compatibility equation, that is CE. EE plus CE, it becomes, the number of equations are equal to the number of unknowns, so that you will be able to find out the unknowns. Now let us draw the free body diagram. To draw the free body diagram, this is a concurrent system. So let us assume that you have the tensile force in OA is T1, in OB is T2, and in OC this is T3. And now you can know downward force is 20 kilonewtons. You can write the equation of equilibrium, that is first you write the sigma fx is equals to 0, sum of all the forces along the x direction. The notation is the force is pointing to the right or positive, and to the left, that is in the direction of x prime, or negative. Here this component is T3, it is a sine component, sine 30, and it is positive. The other component minus T1 sine 30, and observe carefully, you don't have the component of T2 as well as 20 kilonewtons. Both are vertically upwards and downwards respectively. So this equation, so you can conclude that from this equation T1 is equals to T3. From equation of equilibrium, that is sigma fx is equals to 0, you got that T1 is equals to T3. Now let us write down sigma fy is equals to 0, sum of all the forces along the y direction, pointing upwards or positive, pointing downwards or negative forces. So this component here, T1 cos 30 plus T2 plus T3 cos 30 minus 20 is equals to 0. So this equation is T1 cos 30 plus T2. Now, as you know that it is T3 is equals to T1, you can write down again it is a T1 only T1 cos 30 and minus 20 kilo, that is into 10 to the power 3 kilonewtons is equals to 0. So this you can rewrite 2T1 cos 30 plus T2 is equals to 20,000. Call this is equation 1, and this is the only equation you have. Now let us consider the deformation. Because of this external load, the point O, that is concurrent point, will be shifted downwards a little. So let us draw the diagram, deflection diagram or deformation diagram. Assume that it is shifted to O1 point. Now this is a little downwards, it has moved down. So this is the new diagram or extension diagram, and this is vertical and perpendicular, perpendicular. So this deflection, I am calling it as delta. Delta is the deflection in vertical wire, that is T2, that is OB. But it's not same in OA and OC. So here you have, this is, call it as delta 1 is the deflection in OC as well as OA from symmetry. Both are same. So that means now you have a relation. Let us draw this diagram. Magnified view of this, it is at an angle 30, vertical and perpendicular. So this is the delta. This angle, small variation treated as 30 degrees only. 30 degrees, this is 30, and this is delta 1. So from this right triangle, you have a relation between delta and delta 1. So that you can write down. So it is the projection, this becomes hypotenuse. Delta cos 30 is equals to delta 1. So that means delta 1 is equals to delta, it is cos 30. And delta, as you know, you can, it is the equation of deformation or extension. You can replace, you know very well that delta is equals to PL by AE from Hooke's law. You got this equation, stress is proportional to strain. From that equation, you got this deformation equation PL by AE, and substitute appropriately into this equation. Delta 1 is nothing but it is this tensile force, you have denoted it as a T1. So in place of P, you have T1, and in place of L, length of this. So length of this is, so from this right triangle, you can write down, this is your right triangle. So call this as L1. L1, it is this angle is, L1 cos 30. It is L1 cos 30, the projection, your OA or OC becomes hypotenuse. The projection of this along this is your L. So that is 4 meters. And L1 value is 4 divided by cos 30. So this you just make use in the length. So it is T1, it is L1. L1 is 4 divided by cos 30, and A, cross section area, AE is same for both the wires. All are identical wires. So this you can write down delta P. Here delta is your OB wire, that is a T2. So T2 into length is 4 meters divided by AE. So from this equation, this is same, of course, 4 gets cancelled, and you have your T2 is equals to, it is a T1, or T1 is equals to T2 cos 30. So substitute this into your equation of equilibrium, so that you will be getting T1 and T2 values. So T1 you can substitute into this. So 2 T1 is it is a T2 cos 30. Already you have cos 30, that becomes cos square 30 plus T2 is equals to 20,000. And if you solve for T2, calculate T2 using your calculator, you are going to get this value. Tensile force in this is 8.7 kilonewtons. 8.7 kilonewtons, and substitute into this you will be getting T1 value as 6.525 kilonewtons. The forces, the tensile forces in the wires are known now. T1 is equals to, of course, it is T3 also. This is equals to T3. You got the forces in all the wires. Now you can calculate. Is asking diameter is given and is asking what is the vertical displacement. That means he is asking delta also. So just recall delta equation as delta is equals to, it is nothing but T2. T2 value, it is 8.7 into 10 to the power 3. Length is 4 meters. Substitute 4000 mm because all the length units are in mm. And it is A cross section area, it is a pi by 4 d square, d is 6 mm, into Young's modulus is given 2 into 10 to the power 5 Newton per mm square. So you have consistency in the dimensions. Now this you are going to get 6.15 mm. So the vertical displacement of the load is this is 6.15 mm, and this is the other answer. So the answers are T1 is equals to, it is a T1 is equals to T3, and that value is 6.525, and the load, the tensile load in this vertical wire is 8.7 kilonewtons, and of course the vertical displacement is 6.15 mm. Thank you for watching this video.